Howdy, and welcome back to Multar Aviation. So, this is the third video in the aviation weather series. In the first two, we talked about the atmosphere and heat and temperature. And so, in this video, I'm actually going to be breaking it up into shorter videos. We'll be talking about water vapor and specifically the hydrological cycle. So, by the way, I'm Dr. Andy Molter. I'm a CFI, CFII, MEI. I used to be a corporate pilot, and now I'm a professor of aviation. And so, I from time to time, I will teach aviation weather, so you're getting the college lectures just as I would teach them. And so, over these next few videos, I'm going to be talking about water vapor, the hydrological cycle, saturation, relative humidity, dew point, and the change of phase of water. So, water vapor, it's a gaseous form of water. You cannot see it, and it makes up a very small percentage of the Earth's atmosphere from trace amounts like nothing to almost up to 4% by volume. Approximately half of all atmospheric water vapor is below 6,500 feet, and there's barely any water vapor above the tropopause. All right. And so you have to have water vapor for there to be cloud formation and precipitation. It's used as a vehicle for transfer of heat energy, and it's a regulator of Earth's temperatures through absorption and emission of radiation by thermal, infrared, so basically the greenhouse effect. So, it doesn't just stay water vapor. It then, turns into different phases of water through different means by use of the hydrological cycle. And so the hydrological cycle involves a continuous circulation of the water in the Earth atmosphere system. And so the first one you probably know pretty well is evaporation. Evaporation is a phase transition by which a liquid is changed to a vapor. And so approximately 47 inches of water vapor is evaporated from the ocean every year. And it requires an energy source, so like the sun, the atmosphere, the earth, objects on the earth, such as humans. So, for example, when we sweat, the heat from our body heats up that liquid and evaporates, which actually cools us off. So here we have in the picture, you see on the bottom left, you have the ocean or the sea. And so that water, turns from a liquid into a gas by evaporation and then it rises. See over here by the pond, you also have evaporation. And then we have transpiration. So, transpiration is the evaporation of water from plants. So, the plants, pick up, pull water from the ground, but only 1% of the water is actually used for plant growth. The rest of it is passed on into the atmosphere. And so here we have here in the center. I'll zoom in a little bit for you. So here we have our plant in the center, and you can see that there's plant uptake, so it's pulling water from the ground and went through the tree, and then it transpired, and so that water became a water vapor again through transpiration. Then we have sublimation. So sublimation is kind of like evaporation, except for instead of going from a liquid to a gas, it just goes from a solid, so snow or ice, to a water vapor, to a gas. So it never actually turns into a liquid water. Coming from Texas, uh, it does snow and there is ice in Texas during the winter, certain parts. And so, whenever we get snow or ice, uh, we're more likely to get ice where I live, but it would then melt and then it would evaporate. Well, when I moved to Missouri, I was very surprised because, it's snow and I'm expecting it to melt when the sun comes out, but no, it didn't. It just disappeared. I was like, "Oh, what kind of black magic is this?" And then I realized, "Oh, this is sublimation." So, sublimation is that phase of transition by which a solid is changed into a gas without passing through the liquid phase. So, it just goes straight from snow or ice to water vapor. And then we also have condensation. So I'm sure you know what this is. Condensation is the phase transition by which a gas is changed into a liquid. So You're out at some outside restaurant, it's hot outside, and you have a cold drink like lemonade, water, a beer, and it's in a glass. And on the outside of it, it starts to bead up with water. Well, your glass is not porous, it's not leaking out water. If you had a lemonade, how's it just turn into water? It doesn't. So it's just the moisture in the air condenses onto that colder glass. And it's because it reached its dew point, which I'll explain here in one of the next videos. But yeah, so it condensed. And so when we look at our video here, let me magnify the slide. So here on this little mountaintop, we see some the white mountaintop here. It's snow that instead of melting and being surface runoff, this snow right here sublimated. So it just went directly from a solid snow to sublimating into water vapor. And then let's see here. Where do we have? And then condensation. So as it sublimated, so then it condensed. So there was enough water vapor that it would then condense into these clouds. Same thing with evaporation. So you have the water from the ocean that evaporated. And then as it rose, it cooled down to its dew point and it condensed into a cloud. And so for it to condense, there has to be some condensation nuclei. And so if there could be a lot of moisture in the air, but if the air is really clean without any condensation nuclei, that water will not have anything. If you look at the picture of me, let's say my fist is a condensation nuclei, you'd have to have that water that would then attach to that condensation nuclei to then turn into like visible moisture, which is a cloud. So this is the same thing for contrails, not chemtrails. I got a funny story for that I'll say in another video. But yeah. All right, then we have transportation. So transportation is the movement of solid, liquid, and gaseous water through the atmosphere. Without this movement, the water evaporated over the ocean would not precipitate over land. It would just evaporate over the water, become a cloud, and then rain right back into the water. And then we have precipitation. So it occurs when the tiny condensation particles grow through collision and coalescence. And we'll talk about this in another video. And it turns into rain, snow, and other forms of precipitation. All right. So the water evaporated, it condensed. And then we have transportation here at the top left. And so that's where the cloud moves. Clouds can move through propagation or advection, which, hey, I'll be talking about that in a future video. So make sure you subscribe so you can get notified when I make those videos. And so the transportation causes those clouds to move, which will then cause it to precipitate. And sometimes they'll precipitate over the water. Sometimes they'll move far enough that it precipitates over land. And then we have runoff. So runoff occurs when there's excessive precipitation and the ground is saturated. And so the ground can only accept so much water, it becomes saturated itself, that the excess flows into streams and rivers and eventually back into the sea. And then evaporation of this runoff begins the hydrological cycle all over again. Now, some of that water, though, is going to percolate into the soil. So it's going to be soaked up into the ground and it's going to be used by plants and for transpiration again. And then you'll get that there's infiltration. So, infiltration is the movement of water into the ground from the surface. Then we also have groundwater flow. So, groundwater flow is the flow of water in aquifers, and sometimes it may return to the surface through springs, or it can even seep into oceans. Just depends on wherever that water goes. And then we have that plant uptake that, like I showed you earlier with transpiration, where water is taken from the groundwater flow and then and the soil moisture to be used for the plant growth. All right. So let's zoom in here for you. So, like we said earlier, some of that snow is going to sublimate, but some of that snow is going to melt. That's when solid turns into a liquid. Ice and snow turns into water, and that some of it is going to be surface runoff, which it just goes back in as a river or stream back into the ocean. Sometimes that surface runoff, that stream or river will go into a lake or a pond. And then some of it evaporates, but some of it becomes infiltration. So that's where the water goes into the ground. And then you have groundwater flow. So it could be through an aquifer and it can come up through a spring somewhere, or it can just, eventually make its way back out to the ocean or sea. But along the way, those plants are going to take some of that water to use it for growing. All right, well, that's it for this video. In the next video, I'm going to be talking about saturation, relative humidity. If that's something that you've never been too sure about, well, I'm going to make it real simple in the next video. So make sure you subscribe so you can stay tuned for that video. And if you have any questions, please leave them in the comment section below. Happy to answer any questions y'all have. But all right, well, thanks for watching. Take care.